So what is the mole and how does it relate to the SOLAM? And now that we kind of understand how the mole can be used to count up very large numbers of very tiny things using Avogadros number, how does that work mathematically? How are we going to work and solve a problem like we would with the SOLAM? So, just like before, the mole is used to count by weight, just like the SOLAM is, because a SOLAM is sort of like a mole. And instead of counting things like beans in groups like 158, we're going to count incredibly tiny things like atoms. So we need an incredibly large number per group. The tinier the thing that you're counting, the bigger the group that you're going to want to count by. And so the group we're going to count by is Avogadros number. There are lots of illustrations of how big Avogadros number is. Hopefully you'll be exposed to those at some point. That is not the purpose of this lesson. The Avogadros number, it's symbolized by the capital letter A in formulas, and it means that number. 602 sextillion, 213 quintillion, 670 quadrillion, which is not a number you need to memorize, but you do need to know its value generally in scientific notation. That is 6.02 times 10 to the 23rd, 3 sig figs. If you want 4 sig figs, you'd put another 2 on there. And so that's Avogadros number. It's an enormous, enormous, enormous number. About 10 of those is how many kilograms the Earth weighs. It's a really large number. A lot bigger than 158 because atoms are a lot smaller than beans. So these are our old SOLAM formulas, and we're going to see that the math works exactly the same way for the mole as it did for the SOLAM. All we've got to do is change what we call these things. Grams, do we still measure atoms in grams? Well, yes, we do. So we don't need a new unit there. We just need to start calling it atoms mass instead. Instead of using SOLAMs, we're not going to use groups of 158 anymore. We're going to use groups of 6.02 times 10 to the 23rd. So we're going to start using moles here. And the symbol that we're going to use for moles is a lowercase n. Lowercase n. That's what's going to be there instead of the s now. And for solar weight, we're going to use molar weight. Instead of weight mass per SOLAM, we're going to go mass per mole. So we tend to just kind of label that with a capital W for the weight, or molar mass. I apologize for that. It seems like we should call it molar weight if we use a W. But this is the symbology used in chemistry. They tend to symbolize molar mass with a W, and then they tend to say it as molar mass and not molar weight. So that would kind of collapse into G equals N times W, where G is the mass, N is the number of moles, and W is the molar mass. That is the weight per mole. Now, how did we get the solar mass before? Well, we looked at a chart. We looked at a chart that we had produced. Well, how are we going to find molar mass? Well, the same way, we're going to look at a chart. If you want to know the molar mass of an element, you're going to look at the periodic table. For example, if you're doing carbon, you would look it up and you would see that its molar mass is 12.011 grams per mole. That's on the chart. So look for 12.011 where that's placed on the periodic table you're using, and that is the same place that all of the elements will have their molar masses listed. So if you're ever looking for a molar mass, look right there on your periodic table. So just like the solar mass was found on a chart, the molar mass will be found on a chart, but that chart is now the periodic table, not some bean chart that you made. And this other formula, we need to revise it a little bit because we're no longer using beans anymore. We're going to be using atoms or molecules, or really we could count anything with these. And so what we tend to use for this is a capital letter N. That's why we got to be careful with our lowercase n for moles. So whenever we're counting atoms or molecules, we symbolize that number of things, however many there are, with a capital N. And as we saw before, the 6.02 times 10 to the 23rd is no longer 158, but now we're going to symbolize that with a capital A. And of course, instead of solams, we're going to be using moles, or lowercase n. And so that's how it all changes. If that looks a little messy, then you can go ahead and wait for this screen here, where we kind of have all of those things nicely written out. So those are our new two new formulas, G equals N times W, and N equals A times N. Not complicated, but you got to remember what all the different symbols mean. The molar weight or the molar mass. I'm going to go ahead and change that to molar mass because no one says molar weight. But it is, like I said, a little confusing because we do use a W for it. And so those are our two formulas. Units. The capital N, that will be atoms or molecules, depending on what you're finding. If it's like for an element, you would use atoms. And if it were a compound of some sort, you would use molecules. The unit for N, the unit for moles, is moles, of course. The unit for W, just like before it was grams per solam, now that our groups are no longer solams, they're moles, so it's grams per mole. And the G unit hasn't changed, it's just grams. And so that is a summary of where we get our two new mole formulas. Exactly the same relationship. It's the weight. The mass is equal to the number of groups times the weight per group. And the number of individual items is equal to the number in a group times the number of groups. So that is the mole formula in a nutshell. And now we can move towards working some examples, but that's not for this lesson.